If you want an object to move along a straight line, you require a force. If you want the object to rotate about an axis, you require a torque. In this video, we shall investigate what is required to keep objects moving along a circular path. If we had a toy car moving on a frictionless surface at uniform speed, then an opposing force would cause the car to slow down. However, if this force was in the same direction of motion, it would cause the car to speed up. But if this force was perpendicular to the motion of the car would change direction without change in speed. If this car was attached to a rope tied to a fixed support, it would change direction continuously. However, the speed of the car would remain unaffected. Such a motion of the car, in which it is moving along a circular path, is called uniform circular motion. To cause uniform circular motion, a force is required. So where is this force? The force is the force of tension between the car and the fixed support. Since the direction of the car is changing continuously, it means that the force is continuous in nature. Next, the radius of the circular path is neither increasing nor decreasing, which means that the magnitude of the force remains constant. And third, the direction of the force would be perpendicular to the direction of the car's motion, which means that the force would always be directed towards the center of the circular path, and hence this force is called centripetal force. In other words, it is a center-seeking force. Now we all know that a force causes acceleration. So let's find out where the acceleration is in this case. While the speed of the car remains unchanged, the velocity of the car changes continuously. How is that possible? The magnitude of velocity remains constant, whereas the direction of velocity changes continuously, which means that the velocity is changing over time. Hence, we say that the car is accelerating. Now, acceleration is a vector quantity. It will have both magnitude and direction. In this case, the magnitude of acceleration remains constant, and the direction of acceleration will be the same as the direction of force, which means that acceleration would also be directed towards the center of the circular path. Now we know that centripetal force causes a car to move in uniform circular motion. The question is, what would happen to this car if the centripetal force ceased to exist? We might expect this car to fly radially outward from the center of this path. However, what happens is that this car moves at uniform velocity in a straight line in accordance with Newton's first law of motion. Now let's say instead of the fixed support, we had a man exerting a centripetal force. The car would experience a centripetal force, but every action has an equal and opposite reaction. So the man would be feeling a reaction to the centripetal force. Now, apart from these two forces, there would also be a third force experienced by the car, and that is a centrifugal force, a force that causes the car to be flung out of its path. Now, this force is caused due to the tendency of the car to move along a straight line at uniform speed. In other words, it's caused due to inertia. It does not have a reaction force, and hence it is said to be a fictitious force. So the next time you have an opportunity to visit a carnival and witness the wall of death, use your concepts of physics to understand and explain what is happening. And now, the summary of this video. Uniform circular motion is caused by centripetal force. The velocity of a body in uniform circular motion changes continuously. Since the velocity changes continuously, the body is set to accelerate. A body in uniform circular motion also experiences centrifugal force outward. Centrifugal force has no reaction and hence it is a fictitious force. That's all in this video. In the next video, we will begin to understand the concept of work in physics.